Hey everybody, here we go with the solutions video for the Unit 8 practice test. First problem is converting this point into polar coordinates. This point is located in quadrant 4, positive x, negative y, and so that is, those are the legs of a 30, 60, 90 right triangle. You can tell because one of them is just multiplied by the square root of 3. So there's our long leg, there's our short leg, and that means the angle right here is opposite the short leg, which makes it 30 degrees. That makes this angle right here 330 degrees, or 11 pi over 6. Also, the 30, 60, 90 right triangle has this beautiful shortcut. The short leg times 2 equals the radius, equals the hypotenuse, sorry about that, the hypotenuse, and that's what we're looking for here for r. That's the radius that we're looking for. So 12 times 2 is 24. And so our point is 24, 11 pi over 6. You could use the Pythagorean theorem, but you'd have to make sure you did all of that stuff correctly to get the 24. Better, in my opinion, to use just the 30, 60, 90 shortcut. The 45, 45 shortcut is also really helpful, especially when you see that the x and y values are really the same number, or maybe one of them's negative and the other one's positive, but they're the same distance away from 0. So in this case, they're both negative, so it's down here in quadrant 3. Our angle is down here in quadrant 3. That would be from a 45-degree angle there, plus 180, 225, or 5 pi over 4 in radians. And our radius value is just the leg times root 2. Now, of course, you can do the Pythagorean theorem with those numbers, no problem. Well, maybe not no problem, but anyway, it's not too hard. You just have to be careful and do it all right. Or you can use this shortcut, which means taking the x value, 3 root 5, and multiplying it times root 2. That gives you 3 root 10. Pretty easy, really. And then so there's our r value, and the angle that we said is 5 pi over 4. Next problem is going the other direction, giving you polar coordinates, and asking you to come up with the x and the y value, the rectangular coordinates. And this is very straightforward application of these two formulas. X is our cosine theta, y is our sine theta. It works perfectly all the time. Don't have any issues like you do with finding the angle in those guys. So cosine of 240 is negative 1/2. 18 times that is negative 9. There's our x value, negative 9. Sine of 240 is negative root 3 over 2. And 18 times that is negative 9 root 3. There's root 3 again, and there's our two x and y values. This point is down there in quadrant 3. It's a 30, 60, 90 right triangle. Next problem, negative 5 is our r value, and the angle is 7 pi over 4. All right, so x equals negative 5 times the cosine of that. That's negative 5 times root 2 over 2 for x. Y is just negative 5 times the sine of that angle. Well, the sine of that angle is negative root 2 over 2, so negative 5 times negative root 2 over 2 is positive. So our two x and y values, 5 root 2 over 2 and negative 5 root 2 over 2 for x, and positive 5 root 2 over 2 for y. There's our x and y coordinates. Okay, so that point is located actually in quadrant 2, even though our angle is in quadrant 4, but that's because our r value is negative. Okay, moving on. Changing rectangular equations with polar expressions is simply a matter of using the direct substitution. X equals r cosine theta and y is r sine theta. This equation has y squared, so I got to square r and sine theta, so r squared sine squared. The 2 is still there, 2 times r squared sine squared, and that's r cosine theta on the left side. I divide everything by r at first, and that gives me just 2r sine squared on the right, cosine theta on the left, and I'm going to divide both sides by 2 sine squared to leave my r all by itself, and there's my equation, cosine over 2 sine squared theta. Next one, a little more complicated, but it's just more terms. It's still the same idea. I'm replacing x with our cosine theta and y with our sine theta. Doing all of that gives me this first line, and what I did next was gather my squared terms together so that I could factor out r squared. That left me with cosine squared plus sine squared, which, as you may recall from chapter 7, equals 1. There's your fundamental Pythagorean identity right there, folks. So r squared times 1 is just r squared. I still got the 3r cosine from that and the negative r sine, and I moved everything over here to the right side of the equation, of the equal sign, excuse me. So the plus 3r cosine became negative 3r cosine, and the minus r sine became positive r sine. I have r squared equals all of that stuff, and so I'm just going to divide by r to get r all by itself. And there you go. There's your equation. Sine theta minus 3 cosine theta. The next problem, taking this polar equation and putting it into xy terms, my favorite trick in the world is to multiply by the denominator. That's great here because that just gives me r times 3 cosine theta plus 5 sine theta equals 2. No more fraction on the right side. And so then using the distributive property, r times this 3 cosine is 3r cosine, and r times 5 sine is 5r sine. That's 5 times y. This was 3 times x, so 3x plus 5y equals 2 is my final equation. Pretty nice. Next problem, back in, is into complex numbers, and z1 is 2 plus 2i, which would put it in quadrant 1, 2 this way, 2 that way, and that's hard to read, but that is the square root of 8, which you might say is 2 root 2, it's probably better. So our r value is 2 root 2, and the angle, hopefully you recognize this as a 45-45 right triangle because the legs are the same, so that's pi over 4. And so z1 is right here, 2 root 2 for our r modulus, and cosine pi over 4 plus I sine pi over 4. That's z1 there on the bottom. z2 is in quadrant 2, negative 3 root 3 this way, and up 3 for 3i. And so once again, 30, 60, 90, you can tell by the root 3 being there, and the short leg is 3, so double that to get r, that's 6, and our angle here, opposite the short side, is 30 degrees. That makes this 5 pi over 6, or 150 degrees if you prefer. And so z2 is r equals 6. 6 times cosine 5 pi over 6 plus I sine 5 pi over 6. z1 on the bottom, z2 on the top. Moving on. The next problem, I'm taking a number in rectangular form, a complex number in rectangular form, and raising it to the 8th power. So that point locates right down here in quadrant 4, and you really want to put this into polar form first and then raise it to the 8th power. All right? So the r value there is 2 times the short leg, that's 2. And we've got a 60-degree angle here. That makes the outside here 300 degrees. So there's my polar form of that number. That is what I'm going to raise to the 8th power. Okay? And with de Moivre's theorem telling us that all we have to do is take the modulus and raise it to that power. That's 2 to the 8th power, which gives you 256. And then take your angle, your argument that is, and multiply times that value. So 8 times 300 is 400. So there's my angle, which I can reduce down by subtracting 360 a bunch of times. I get 240 degrees. So the cosine of 240 is negative 1/2, and the sine of 240 is negative root 3 over 2. All right? So all I have to do is multiply 256 times those values. And 256 times negative 1/2 is negative 128, and 256 times this is negative 128 root 3. So there's my a plus bi form of that number. All right, so once again, that number, 1 minus root 3 times I, all that raised to the 8th power gives us this. Okay, next problem. These next two are kind of easy. All you got to do is multiply these two numbers together. You multiply the moduli. So there's 10 times root 2 is 10 root 2. And you add up the angles. 15 and 210 is 225. So, and then to put it into rectangular form, a plus bi form, you multiply the modulus times the cosine and the modulus times the sine. Sine of that's negative root 2 over 2. So is the sine. Is negative root 2 over 2. So 10 root 2 times that equals negative 10. And you can work that out with the square roots and everything, but it should get a nice, friendly, round, even negative 10. And so our number is negative 10 minus 10i. That's what we get by multiplying those together. Dividing, all you got to do is reverse that process. Divide the two moduli and subtract the angles. You can practically do this in your head. 15 divided by 3 is 5. And 3 pi over 4 minus pi over 4 is 2 pi over 4, which I'm writing as pi over 2. So the angle is pi over 2. 5 times the cosine of that angle, because once again we want to put it into rectangular form. So I multiply the r times the cosine, r times the sine. Cosine of that number is 0. Sine of that number is 1, so 5 times 1. That's 5i. That's my answer right there. Next problem, I'm taking a graph here. And just wanted to show you this, how I got these numbers. there's my equation, all right, and I'm given a value for theta and asked to come up with the r value for that point A, right there. There's point A, and the angle is pi over 4, all right, and, oh, wait a minute, that's the wrong angle. Dang it, should be pi over 3. Anyway, I figured it out, so that's here's pi over 4, that's my new A value. Oh boy, gotta fix that. Oh well, that's A is pi over 4 right there. That's where that point should be located, not here. Pi over 4 is right here. This is the pi over 4 radius. Okay, sorry about that, folks. But anyway, when I put pi over 4 into the equation, here's your equation, here's theta, all I do is, just kind of work it out. Just do the number crunching. Cosine of pi over 4 is root 2 over 2. 4 times that is 2 root 2. 2 plus that is about 4.828. So that's my r value right there. Okay? Yeah, that's about right. There's 4.828, just a little bit under 5. Oops, there we go. And now you can see it. There's my point, new point A. All right, point B is, let's see, that's over here on this piece of paper. And point B, the angle is 5 pi thirds. All right, that one I got right. There's 5 pi thirds, there's point B. So my angle, 5 pi thirds, I put that into the equation. Cosine of 5 pi thirds is 1/2. 4 times that is 2. 2 plus 2 equals 4. And so there's my r value for point B, 4. The next problem is I'm taking another r value, 3 pi over 4, and replacing that into the equation. All right, that looks like this when you work it out. For cosine of that is negative root 2 over 2. 4 times that is negative 2 root 2. And so 2 minus that is negative 0.828. Check it out. We've got a negative r value here. All right? And that point actually plots down here in quadrant 4. The angle is this way, 3 pi over 4. But if the r value is negative, the point is in the opposite direction. So it plots right there. And that's it. That's as far as we're going to go. I am not going to have a problem like this. The answer is A for this last problem, but not going to really go into it. Try to keep my video a little bit shorter. And all right, so there's the last look at problem number 9. Enjoy!